We've now discussed and created a feature where a user can limit their housing search results to be within a specific travel time of a point that they care about, like work. However, how can we give them more detail? Users don't just want to know how long it will take them to get somewhere, they also care about how they'll get there. If I'm taking the subway to work every day, I want to know that I'm not going to have to switch trains 3 times, take a ferry, or maybe I want to see multiple options for routes in case a service goes down. Luckily, we have the ability to get and show the user the information they need about how they would travel from their potential new home. The Directions API, much like the Distance Matrix API, gives us information about a journey. However, instead of just the time and duration, it provides step-by-step directions from point A to point B, and even to point C through Z if needed. Many of the same inputs can be used. The travel mode of either driving, walking, bicycling, or transit, multiple transit modes, such as bus or train, and restrictions, such as avoiding tolls, highways, or ferries. Directions can specify origins, destinations, and waypoints as either text strings, for example, Chicago or Sydney, or as latitude-longitude coordinates. The Directions API can return multi-part directions using a series of waypoints or via points. We'll demonstrate the request and response again through a web service request within the browser. So once again, we have the same URL route. We're using the directions service this time, and we're specifying we want our output in JSON format. Now we need the required parameters. For Directions API, we need a single origin and destination pair. We can make them specific, like lat-long coordinates, or very general, like cities, which would then use the city center. Finally, you need your API key. Before we look at the response, let's talk about other possible inputs to this request. This particular request would default to show us driving directions from the center of Brooklyn to the Google New York City office. As with before, we can optionally add in a travel mode and a bunch of other things. The instructor notes has a link to our documentation with a more complete list. Let's set our mode to transit, since I'm probably going to take the subway or bus to work. When I'm using transit, again, I can specify the transit mode, for example, subway. I can also specify the transit routing preference, whether I want less transfers, less walking, etc. I usually choose less walking, contrary to many of my Fitbit-wearing friends. We can also, again, use bicycling so that we have a scenic bike ride to the office. But if I do that, I'm going to want to stop along the way. Luckily, I can add multiple waypoints. Let's say I wanted to stop off at my favorite bakery, then continue on to work. I can use the waypoints parameter to specify an additional destination, which is taken into account as a stop in my route. Alternatively, if I just wanted to pass by and smell the bakery, I can specify via instead of waypoints. And then my route won't consider it an extra leg, it'll just take me by the place. So let's execute this request and see what kind of stuff we get back. First, I'm going to execute my transit route with my subway specified and less walking specified. As with the rest of these service requests, we get a status. OK is the one we want. If the request had failed, status would not be OK and you wouldn't see a route in your response. Next, we'll see the geocoded waypoints. This is essentially taking our origin, destination, and any additional waypoints and making sure the service was able to successfully find that location. It gives us the lat-longs as well. We only see 2 points here since we had no waypoints. This is our origin and our destination. The next thing we'll see is the route data itself, so let's expand this. There will only be one leg if you didn't specify any waypoints, but the route will be split into multiple legs if you did specify waypoints. Each leg has a duration and a distance, and a start and end location. Each leg also has one or more steps, a step being the smallest unit of instruction. For example, walk to Kingston Throop Avenue. Each step also has a distance and a duration, so there's some very granular data here. Each leg also has an overview polyline. This is what will allow us to display the route in our map. Finally, we see any warnings. For example, if there's no walking or biking path and you specified bicycling, the response will tell you that. Let's execute our biking request with the waypoint to see the difference in the response. So the first thing you'll notice is that we have 3 geocoded waypoints here. one for our origin, one for our destination, and one for our waypoint. We also have 2 legs, unlike last time where we had 1 leg. The first leg here will be from our origin to our waypoint, which is Tompkins Square Bagels, by the way. It's delicious. The second leg will be from the bakery to my office. As we talk about going from point A to point B and making stops along the way, it sounds a lot like the traveling salesman problem, where he has to plan his journey to cover a number of different clients at different locations in the most efficient way. The good news is the Directions API can do that for you too. Here, we'll execute walking directions using 3 waypoints. Notice that they're pipe delimited in this request. The response will have 4 legs, and the order of the points is in the order that we specified them in the request. But you can add in the optimize true prefix when you specify waypoints. What this does is it will do the planning for you to cover all the stops in the most optimized way. This means that the result may change the order of the waypoints from how you originally provided them in the request. Notice now the order is different. Our first address was 350 Fifth Ave, but our first stop is actually going to be 165 Avenue A. It's optimized it for us.